And those V-notch weirs, which I wish I'd brought a picture of one of those. There may be one in the brochure. Is there one in there? Well, this is our big one here on the cover, but you can't see the V-notch in it. It's essentially a wall with a V in it. It's a wall across the stream with a V in it, a notch out of the wall that's shaped like a V. And so the height of the stream in that V-notch is related to the flow of the stream. So we have a rating equation. The rating gives us an amount of flow for the height of the water in that V-notch or above the wall. So there would be different ratings when it's in the notch or above the wall. So we take these flow proportional samples. We bring them in either weekly or biweekly, depending on the time of year. And we analyze them for nutrients. At a couple of sites, we analyze them for, and I'll get what nutrients we analyze for in a minute. A couple of sites, we analyze them for a suite of pesticides. We also use a YSI multi-sonde probe, which basically is just a device with a pH probe, a conductivity probe, a dissolved oxygen, an oxidation redox potential probe. We actually sometimes will be using a nitrate probe or an ammonium probe on those, and we take those measurements each time we pick up the sample. So those measurements are made either weekly or biweekly. So we have a lot of nutrient data and actually a lot of pesticide data from the upper part of the Little River watershed and also from the larger watershed that I was talking about earlier at those 5 sites. In general, our nutrient water quality is very good. When we compare our nutrient levels on these agricultural watersheds to nutrient levels on agricultural watersheds in the Midwest, especially for nitrogen, they really can't even be shown on the same graph because their concentrations are an order of magnitude or more higher than ours. So in general, our nutrient concentrations are relatively low for agricultural watersheds. There are a number of reasons for that. One of the reasons is that they never did to these watersheds in the upper part of the Little River. They never did what they thought they were going to do, and that is they never did extensive ditching and draining of the watershed. We've never been able to find this in writing, but the lore of our research is that they wanted to put the watersheds where they did in the upper part of Little River because there was a plan to channelize Little River and allow the watershed to be drained with artificial drainage. And if they had done that, we would have probably had more interesting research because of the fact that then we'd have more water quality problems. Because basically what you do then is you decrease the residence time of water in the soil and in the watershed, and the faster the water moves in subsurface flow, the more dissolved things it carries. And by dissolved things, I mean things like nitrate and soluble pesticides. So we don't have those problems because it takes a long time for water to move in the subsurface out of our watersheds. And in the process of moving in the subsurface out of our watersheds and in surface runoff, it mostly has to go through these dense riparian forests that have been left along the streams. We've studied the riparian forests, and riparian just means stream side. So we've studied the riparian forest down here since about 1979. We had a basic idea of how they worked by around the mid-'80s. Then we started, as you know, like I said, we do research. We have to say, well, what if we did this? So we started manipulating things. We started cutting the forest in different ways. We started reestablishing forests in different ways and looking at how long it took to get this effect of improving water quality with these stream side forests. So we have a lot of things done on that.